Welcome back to another video about the SmartWood 3D project. In a few minutes a big wood chopper will show up and we will process a whole load of large wood which we collected further upstream at engineered retention racks. And the previous video was about sensor tagged logs, so-called SmartWood, which were tested for the first time in the field in order to gain new insights into log mobilization, transport and the positioner processes. In today's video we are extending on the positioner processes and the clearing of resulting large wood accumulations from engineered retention structures. So the big wood chopper just showed up, so I will basically this provides a great opportunity for scientists and researchers to study large wood accumulations at a field scale and allow for a better prediction of resulting effects on flow hydraulic and general morphology in future. At this point, I want to thank the local community Saanen and in particular Mr. Sepp Berchtold for the great support throughout this study. So the assessment of large wood accumulations basically starts with the mapping process or the surveying of the wooden deposits, which is typically achieved using drones or laser scanners. In the present study, we are exploring the performance of a structure from motion photogrammetry approach for utilization in large wood research. To do so, drone footage is imported into Pix4Dmapper, a Swiss structure from motion photogrammetry processing software for computing digital twin models of the prototype deposits. At first, this digital twin is represented by a dense point cloud model, which is used for initial volumetric estimates based on the 2.5D approach, which is directly offered in the Pix4Dmapper software. This requires, however, the generation of a digital surface model. The 2.5D approach yields the bulk volume, which can be imagined as the volume beneath a thin blanket covering the entire large wood accumulation. So basically all the void space which is accessible from the outside is considered as volume with the 2.5D approach. At a later stage, the point cloud is meshed and further processed into a manifold mesh model, meaning that all gaps in the mesh are fully closed. In other words, a watertight model is generated from which precise volumetric measurements can be obtained. After the registration of the large wood accumulation in the field, the deposit is cleared from the engineered retention structure and brought to a site nearby. Here, all organic material is processed into wood chips. The total mass and wood chip volume per examined large wood accumulation is carefully measured. In addition, samples of the wood chips are brought to the laboratory where density estimates are conducted using the water replacement method, which then allow for the estimation of the net wood volume, also known as the solid cubic meter volume in industries. With the knowledge of bulk and net wood volume, large wood accumulation porosity is estimated. It is known that large wood accumulation porosity affects flow hydraulics and general morphology. However, it is important to note that the structural alignment of wood accumulations is also anticipated to show significant effects on flow hydraulics. For this reason, a new parameter, namely the backing arrangement, is introduced to provide information about the structural alignment on basis of the gained volumetric measurements from the digital twin models. The backing arrangement parameter considers the ratio between 3D and 2.5D volume. As an example, framework deposits can show similar porosity parameters than large wood accumulations for significantly varying structural alignment or backing arrangement parameters in turn. So, all in all, this study should contribute to an improvement of non-intrusive surveying techniques for the application in large wood research, which is needed to estimate and predict flow hydraulics in the presence of large wood accumulations, but also to design and optimize intentionally or initially installed large wood accumulations, so-called engineered logjams, which are employed for the enhancement of diversity and complexity in river restoration projects. Thank you very much for watching and following the updates on the SmartWood 3D research project.